Hi guys, welcome to our new course on TCP/IP stack. This course is all about development of TCP/IP stack from absolute scratch. Now we already know the entire networking universe is actually defined by these four layers of the TCP/IP stack, right? So in this course we will going to see how to implement the data link layer and the network layer essentially, because these two layers are essentially responsible for carrying out any type of routing in the network. So this course is divided into two parts, the part A and the part B. Part A essentially deals with doing some groundwork in order to do the part B. So in part A of the course, we will going to set up an infrastructure which will enable us to implement the part B. So needless to say, part A is a prerequisite of part B. Now what we will going to do in part A of the course? In part A, we will going to define what are project goals, what are the prerequisites, and after doing this project, what will be the takeaway? What will you going to learn? We will going to write a library in order to set up a generic graph. So we will have a library which actually implements the graph data structure, and we already know that the graph data structure contains nodes and the edges connecting nodes. You can use this library in future in order to solve or implement any graph-based algorithms or problems. In the step 3, we will going to extend this generic graph into a network topology. Now when I say network topology, it means that the node of the graph will represent a routing device. A routing device could be an L3 router, or it could be an L2 switch, or it could be hub. And the edges which connects these routing device will be called as links. So after step number 3, we will going to have a graph data structure which actually represents a network topology. Now since the nodes of the graph will represent routing devices, in order to interact with those routing devices, we would need a command line interface. So we will integrate an existing command line interface library to our project so that as an end user, we can configure our network topology using command line interface. And since it's a prerequisite that the nodes of the graph which represents routing device should be able to carry out packet exchange with the neighbors. So in the step number 5, we will going to set up packet exchange simulation between the nodes of the network topology. After step number 5, our routing devices, which are nothing but the nodes of the graph, will be able to carry out packet exchange with their neighbors. Now once we accomplish all these 5 steps, it would essentially means that we have a network topology which you can use in order to implement any kind of networking related problem or solution and demonstrate the network concepts. So in part B, we will going to use this network topology in order to implement the complete L2 routing as well as L3 routing. So in part B, we will going to start how to implement the ARP protocol, and we will see how MAC forwarding is implemented. You will be writing the entire code in order to implement these functionalities. After that, we will going to implement layer 3, which is nothing but a layer 3 routing altogether. You will going to implement that how L3 router forwards the packet from one router to the next so that the packet reaches its destination. And of course, we will going to test whether our layer 2 and layer 3 functionality works correct or not by writing a dummy application such as ping or trace route, right? We will going to use this application in order to test the functionality that we have implemented in layer 2 and layer 3. And probably as a sequel of this course, we will going to implement the dynamic construction of layer 3 routing table. In this course, we will see how routers of the topology actually interact with each other in order to populate their layer 3 routing table dynamically. So this part C of the course will be launched as a separate course and it is not a part of this course.